In this project, we try to design an analysis of a hybrid power system for an Iranian island, especially Hark Island. The objective view of this project is that we are focusing on finding the best hybrid scenario by using the hybrid optimization model for an electrical renewable system with help of Homer software. Since the lifespan of a hybrid power system and its affordability to end users will be significantly impacted by the component of generation source used. Consequently, appropriate system sizing should be the top focus in order to achieve cost saving and efficiency. With the Homer software, a power system designer can give a crucial overview that compares the cost and uh, viability of various configurations and assess the technical performance of the power. Totally, there are several parts that make up a hybrid power system. When creating a hybrid power system, variables such component size, system topologies, and the sufficiency of a decision maker will be assist in the identifying the most cost-effective hybrid system solution to meet the electrical loads. This system is being designed by the region's various renewable energy sources, project economic with changing load and components costs. Additionally, this system's life and additionally the system's life cycle, net present value, cost of energy to the end user, maintenance costs, and annually operating costs are considered. Looking from an overall view, Hark or Harg Island is a residential island in the Persian Gulf Sea in the south part of the Iran. Harg, with a population of above 8,000 people, has an area of 20 square kilometers. As well, Harg City is the only area situated on Harg Island. Due to its geographical location, it has potential to produce electricity from different resources such as oil, wind, solar, and tidal. According to geographical location of Hark Island, in general, the government uses distributed generation method to supply electricity to Hark Island. Furthermore, Hark Island plays a crucial role in Iran's oil and gas industry. Therefore, to be sensitive to this issue, the government divided two parts for supplying electric energy to Hark Island. First part consists of generators. Generators provide resistant and public and commercial with a spider power network. And the second part is about the oil and gas industry that each company supplying its electricity as a private. We will design an analysis first part, power sources and consumption in this project. According to collecting information from Bushehr Electricity Distribution Company, first part has supplying through two power plants. One is a gas power plant with four gas turbines and a 3.5 megawatt rated power, and another is a diesel gas hybrid power plant with a 25 megawatt rated capacity. It needs to mention that due to being old and worn out of the gas turbines, their output power rate is less than 3 megawatts. As for the project sizing, we try to use Homer Pro software. At first, after selecting our location here in this project is Hark Island in the south of the Iran, we need to import our hourly loads into this software. In this project, we have two different kind of overall load. One part is related to commercial and public sector of the Hark Island, which is around 21 megawatt, and another part is related to residential area, which is about 27 megawatt. And in this system, in this project, we try to generate and distribute these needs to the city of the Hark in this island. The next step is that to upload the sun irradiance, temperature, and wind speed of that island to calculate the desired output from our PV panels and wind turbines, and the combination with grid or generators. Then, according to our needs and our loads, we can select our desired PV panels and wind turbine, which I'm going to show you the feature of these components later. By giving these data to Homer Pro software, we can calculate calculate the system and reach the optimized combination of these components, and reach the best way to choose how we can combine these components together. In this project, we use generator, batteries, converter, PV panels, and wind turbine for each load. According to the power curve of our wind turbine and wind speed at the height of 50 meter, our selected turbine can make a large contribution in generating our required power. As for the PV panels, we use monocrystal PV panels. Although crystal PV panels are expensive, they have high efficiency in high temperatures. According to the original feature of the Hark Island, this island experiences high temperature more than 1500 degrees Celsius many months of the year. So monocrystal PV panels could be a really fantastic choice for this project.
Let's demonstrate the model of battery. This plug represents the general battery, as you see in the picture. it has the integral that can save the voltage, and with controller we can for example measure it is full or not, and absolutely it's charging or discharging. About the formula in the box, R is for resistance, internal resistance, A for amplitude of the exponential zone, B for time constant inverse of the exponential zone, and as you see, V for voltage of battery, and small I for current of battery, and the integral with I dt, actual charge batteries. The crucial initial stage for designing is dynamic simulation. We can optimize and improve the control and improve the performance analysis in dynamic modeling as well, and studying the dynamic characteristics of the wind turbine PV panel. Specifically, in the wind turbine, we can measure the errors and for example, some weaknesses of the wind turbine as well. As you see in the dynamic simulation, we have a PV panel and wind turbine and generator as well. Also, we use a battery. It can be the backup battery as well, because sometimes it's not good for PV, and so, because we don't have any sun, sometimes it's not good for PV panel. And as you know, all of the generators has their own overhaul, and in overhaul, all of the generator is shut down, and we have to, for example, save the electricity to use it for residential and commercial. And for these island, as you are aware, the commercial part is really crucial and necessary, because it's for exporting the oil and something like that. Now it's time to the control system. There are numerous justifications for utilizing hybrid system approach when analyzing and designing control systems. Hybrid methods are mainly motivated by the significant interaction between the continuous and discrete components of a system, which can arise when planning discrete action in the context of continuous process. Another key rationale for using hybrid techniques is the need for hierarchical control organization in many of today's intricate um, technical systems, such as those found in flexible manufacturing. Hybrid system theory also offers a convenient framework for modeling engineering systems that have multiple time scales. It's very important. Fast dynamics, it can be abstracted away and treated as discrete changes that affect slower dynamics. Um, there are multiple reasons why you use model of hybrid system and why it is necessary. Firstly, modeling abstractions such as hierarchical organization of a complex system, and time scale separation of continuous components naturally results in a combination of continuous and discrete behavior. Secondly, high-level control of physical plans often involves sequential planning algorithms that are executed by either humans or computers. These algorithms depend on continuous variables and have safety and quality constraints. Finally, rigorous and accurate modeling of embedded control systems requires a hybrid formalism that captures the interaction between the logics implemented through hardware and software, the continuous dynamic of physical plants, and their interfacing components, such as sampling device, quantizes, and communication channels. This is the simulation of wind turbine. We have a supervisory controller, and it's the turbine state machine, and it's wind speed and turbine speed. The speed of turbine is really important for supervisory control, and it can be resulted for the state of turbine, the trip of generator, and the parking brake as well, and the brake of pitch also. And we have a turbine pitch controller as well, and the inputs, the most necessary things for pitch controller is wind speed and generator power. And we can, for example, use it for pitch angle as well. We see the MPPT controller with a limiter controller. And why we use MPPT? For using the maximum current and using the maximum current. It's really crucial for generating the electricity. And we see the whole part of the wind turbine as well. Here is the model of the PV array, and it's completely to the connected to the grid, because PV array is not all of the hybrid system, even wind turbine and PV panel doesn't have their own reliability and consistency as well. Because of this, we have to use the grid. That grid is come from another city through the water, under the water, with the tunnels. They transfer the electricity with these. And as you see, we have a VSC control and MPPT controller using with aptitude and observe technique as well. And here the whole model of the PV array. In the conclusion, we used Homer to determine the best optimal sizing, and in because as you are aware, and the cost is really crucial for industry, for houses and something like that. We used Homer to get a optimal and best result for using the wind turbine and all of the renewable energy. And system components have been modeled in the MATLAB individually, and then combination system has been modeled. Because first of all, we have to use one of them, and then combine them. And there are lots of scenarios for solar system and PV panel as well. We have to use the optimal one. And MPPT and supervisory control is really crucial for controlling the renewable energy, renewable systems, and especially in the hybrid system. For the last, the south of Iran, temperature of the south of Iran is really high, and we have to use the convenient one. And as you know, the currency of Iran is really low as opposed to the, for example, international. And so always using, for example, in that part of it, specifically and in that part of the Iran, using the fossil fuels and something like that, it's really convenient because it's the heart of the oil there. And unfortunately, most of them use fossil fuels and mazzots for generating the electricity. But fortunately, the government has lots of plan for substitute the hybrid system to the others. For example, like, hybrid system and something like that. No, fossil fuels and something like that. And we hope to get them soon. Thank you for listening us, and I appreciate.